my name is Bill Renault. I'm the Inside Sales Exec with K6. Happy to talk to everybody today. I'm looking forward to the structured walkthrough that we have for all of our guests. So I'm going to go ahead and start sharing my screen, and then I'll take everybody through the standard walkthrough that I provide with the K6 Cloud. Here's how we're going to structure it for today. We are going to cover the K6 Cloud GUI. From there, we'll move into test authoring. I'll show how the test builder works in addition to our script editor. From there, we'll move over to the local IDE. We'll show you an engineered test script that we have available. We'll walk through that, show you some tips and tricks that you can include with inside of your own test scripts or even optimize those. And then finally, we'll open up with the K6 CLI, show you how we can bridge the K6 open source solution into the K6 Cloud. And then finally, we'll be wrapping up with metrics, visualization, and analysis with inside of the K6 Cloud. So starting us off here, we're logged into the K6 Cloud. We're immediately presented with our project dashboard. Taking a look, all of my tests are organized into cards here. And picking on my Insights demo with Cloud execution test, I can see some high-level metrics about my tests, such as the last execution time, the average response time, the total number of virtual users, and the total test duration of my test. Coming down to these individualized test runs, if I hover over those, I can visualize the 95th percentile metric generated in milliseconds, as well as the test execution date and time. At a high level here, I can see that most of my tests are taking approximately 69 milliseconds to complete. Thus, I can infer that there are no major performance regressions at a high level. So if we were to compare this to, let's say, our Crocodile API test that we have here, we can see that our initial test took about 4,000 milliseconds. And as performance started to scale up here, and there were introductions of new features maybe here, we saw that performance trended downwards. And we have this major performance regression where performance is taking about 10 times the amount of time to execute this test according to the 95th percentile. So here I can infer that there's a major performance regression and that I need to do some remediation behind this test. Now, changing gears a little bit, we've included numerous ease of use and convenience features with inside of the K6 Cloud to make everyone's life a little bit easier. I imagine everybody watching for today has used a search bar at some point. We type in demo and we can quickly find our Insights demo test, our simple demo, or our browser demo test. In conjunction to this, we have the ability to sort our test cards by the last test run when they were created or a specified name to our test. Now coming up to the top here, we have our K6 project folder. We have our unique project ID. If I hop around, let's say I change to the K6 development folder, my project ID immediately updates as well as the cards with inside of that project folder. The project ID is essentially how the test will be aggregated with inside of the K6 Cloud and how those subsequent test runs will be associated with those tests. Now changing gears a little bit more here, if we come to the top left-hand corner, we have this drop-down arrow. If I click it, I can visualize my individual account settings. Most notably is an API token, which we can use to authenticate our K6 Cloud account via the K6 CLI. And we do have some organizational settings as this is an administrative account. Most notably with inside of here is your members tab. This is how you're going to add new members to your subscription. And so we're going to invite new members to this org. I'm going to pick on Nicole because she's the host for today. And let's say hypothetically we have Nicole as a new junior developer or QA. So we're going to set her up as a project member. And let's say we want to give her access to the K6 project. So we can come down. We see our K6 project here. We select that. And then we click the send invitation button. Immediately after submitting that invitation, Nicole will receive an email. She's able to get started on the K6 project folder. And we have peace of mind knowing that she doesn't have access to maybe our Grafana demo or our e-commerce site. I'll call out here in addition, so we have no limitation on the amount of users that you can add to a K6 Cloud subscription. This increases collaboration as well as decreases cost overall. I know it's a key differentiator between K6 and some of the market leaders that have per seat licensing. In addition to this, so we have numerous integrations for SAML SSO. We currently support Okta as well as Azure AD natively, and we've currently opened up support for SAML 2.0 providers. So as long as they follow the 2.0 protocol, we should be able to support those integrations. Now, changing things up a little bit, we're going to come over to the left-hand side here and take a look at our projects-based foldering system. With inside of here, we are allowed to set up additional project folders where we can store our test cards. We've seen clients break this up in a number of ways based on the web application that's being tested, the project, the development environment, whether that be staging, pre-production, production, all the way up to development, or even across the specific protocol that's being tested, whether that's HTTP, HTTPS, WebSocket, or gRPC. At the end of the day, it's just a foldering-based system, and we encourage all of our clients to use it as such. Now, I will call out here that there's no limitation on the amount of projects that you can create with inside of your K6 Cloud account. Coming down, starting with our manage section, we have numerous features with inside of here that make analysis and integrations a lot easier with inside of the K6 Cloud. Starting off with our threshold section. At a high level with inside of here, you can monitor all the thresholds that are included with inside of your test. We can sort by a specified project, the status of our threshold, or even a defined period of time. At a high level, we can see the total thresholds that we've created, total failed thresholds, and even the failure percentage rate. If I were to come down, we have links to our projects as well as the tests that house those thresholds. And with inside of the history section, I can monitor the regressions of these thresholds. Taking a look at the check failure rating that I have here, I can see that this is consistently failing across my tests. So either I set this up to consistently fail, or there's a major performance regression here that I need to do some remediation around. Moving down to
That was a new feature, wasn't it? I think we
Yes, it
only released
was.
that a few weeks ago.
Yep, absolutely. It's one of the newest features that we've integrated with inside of the K6 Cloud. Both of our front end and back teams diligently worked on this feature to get it integrated within the most recent release that we've had. Cool. So picking up here, we also have our test scheduler. So if you're not looking to integrate with inside of a CI/CD pipeline, the test scheduler allows you to define a schedule for any one of your tests with inside of the K6 Cloud. Extremely beneficial if you're looking to schedule maybe a one-off schedule for one particular test, and maybe you want to run that at 3 o'clock in the morning when you know that no users are with inside of the web application you're testing against. You can define a schedule with this add schedule button here. And with that schedule, we can see the activity, the first run, the next run, frequency, when that frequency ends. We have a link to the specific test as well as an editable button if you need to change that schedule. Coming down to our notifications. So we have the ability to configure notifications from within inside of the K6 Cloud web app. If I come over to this create new notification button, you'll see we have native integrations with inside of Slack, Microsoft Teams, as well as the ability to create a custom webhook or even an email template. If I click this create button, you'll see some of the parameters that we can pass as part of our webhook or email template, such as the test organization ID, project ID, test ID, URL, etc. And to show you some of the triggers, we can trigger a notification based on the test starting, finishing, failing, timing out, or aborting by a number of conditions. Now coming over to our Cloud APM section, this is also a new feature that we've integrated with inside of the K6 Cloud. With inside of here, you can create new configurations for any of your Cloud APM tools, whether that be Azure Monitor, Datadog, Grafana Cloud, or even New Relic. So with that, we're going to come on down to our save tests. So these are tests that are excluded from our data retention policy, depending on the subscription being considered or maybe your testing requirements. We have the ability to save test results based on a specific duration. That duration could be either 30 or 90 days if you're looking to go with one of the self-service plans. Additionally, we do have the ability to configure custom data retention that can be associated with your K6 Cloud subscription. This is extremely beneficial if your organization has a compliance requirement that mandates you hold on to your performance data for a given period of time. So with that, we can configure custom data retention attached to your K6 Cloud subscription. Last but not least, with inside of the manage section, we have usage reports. So with inside of here, you can gain a comprehensive overview of all the usage metrics that are being generated behind your K6 Cloud subscription. We can sort by a specified project, a contributor to one of our projects, or even a defined period of time. With inside of here, as mentioned, we can gain a comprehensive overview of all the usage metrics. We have links to the projects as well as the most recent tests that have been run with inside of the K6 Cloud. And this was actually brought to us by one of our enterprise clients. They had mentioned the need to see their usage metrics in a meaningful way. So we did incorporate this feature. And so with that data, they were able to generate a predictable forecast for their load and performance testing times with inside of their development cycle. So at this stage, we have our usage reports, and we're going to change gear a little bit. We're going to come down to our Explore section and pick up here. So K6 has numerous open source integrations and tools that could be leveraged in tandem to both the K6 open source software and the K6 Cloud. Starting first with our HARDA K6 converter. This is associated with a public GitHub repository where the solution can be cloned to your local machine and leveraged from there. And if you've used Chrome's development toolset in the past to record a user journey and you did capture the HTTP archive recording, we can take that file and then convert it with the converter to a K6 JavaScript test file. The same could be said also for our JMeter to K6 converter for JMX files, Postman collections, and OpenAPI and Swagger files as well. In conjunction to this, we have numerous integrations with inside of popular CI/CD tools. Depending on the CI/CD tool that you're using, we have a write-up composed by our development staff that walks you through integrating K6 into that CI/CD solution. And with that, also shows you how to configure the YAML file as well, which governs the pipeline. Now, I am by no means a DevOps guy. I was able to follow the GitLab write-up and then integrate K6 with inside of GitLab. I have this pipeline set up on a schedule, but I could also run it manually from within inside of here. And then here we can see that my build is starting. I'm going to deploy it and then run a cloud test against my web application. So picking back up here, we have a link to our documentation, API reference if you need to brush up on some of our API documentation, CLI reference if you need to take a look at some popular commands that can be triggered from our CLI and ported to the K6 Cloud if need be. And then my favorite, the support button. So if you run into any issues with your K6 Cloud account, just fill out the support ticket and we'll get back to you in a period no greater than 24 hours. So we're going to come back with inside of our K6 project folder, and we're going to get into test authoring here. So at the top right-hand corner, we have this create new test button and one on the left-hand sidebar here. If we click that, we're immediately loaded up with two unique options. We have the test builder and the script editor here. Starting with the test builder, so if your team has a high-level understanding of JavaScript and they want to lean on our GUI to maybe test against some of their APIs, you're more than encouraged to start with the test builder. However, being that we are K6 and we pride ourselves on the developer experience, we always start with the script editor. So if your team, your engineering team, loves JavaScript, feels comfortable with JavaScript, and wants to script out their test scripts, you may use the script editor, and we're going to start here and transition into the test builder a little bit later. So immediately after I click that start scripting button, I'm loaded up with a boilerplate here. I have my initialization context, options object, and export default function. In terms of K6 JavaScript test files, these are the three primary components that comprise all K6 JavaScript test files. With that, we have our initialization context. We're importing any dependencies, any methods that we'll utilize with inside of our scripts. We have our options object, which houses our stages or ramping profiles to our test, which essentially are defining how long our virtual users will be sticking around inside of our test script, how quickly they'll be entering, and when they'll be exiting as well. Additionally, we have thresholds. Now, thresholds are very important when it comes to K6. They are a binary pass-fail criteria established to generate a non-zero exit code with inside of your test. And then we have our extension into the K6 Cloud where we spin up our load distributors on AWS currently. Coming down to our export default function, this is the main housing for all of the logic behind your test. Now we're going to change gears a little bit. We have numerous scripting examples that can be leveraged from within inside of the script editor. If you're looking to do something with authentication, cookies, correlation of data, uploading files, extracting values or tokens, you can utilize any of these scripting examples. So to show you a basic authentication example, again, it's the same architecture overall: initialization context, options object, a few globally declared constants that we'll be using within inside of our logic, and the logic stored in our export default function. Also, from within inside of the K6 Cloud or the script editor, we have the ability to upload a HAR file as well as record a browser scenario. Now, we do have a companion tool to this in the form of a browser extension. So I'm going to hop over to my fake e-commerce store here that was set up by Tom. Thanks, Tom. And we're going to go ahead and kickstart our browser extension. Note that this is currently supported via Google Chrome and Mozilla Firefox. So we're going to start our recorder here to capture our HAR file. We're going to go ahead and just maybe go through a standard user journey. Maybe I've just created this beanie, and so I want to test the functionality of that beanie, ensuring that my users can purchase this item. So I'm going to go ahead and add this to my cart, view my cart. I see that the beanie has been added, so that's a good news. Perfect. So I'm going to come down. I've passed some dummy data within inside of here that's been saved via my cookies. At this stage, I'm going to go ahead and place the order. And at this stage, an order confirmation should be generated, and I can stop the recorder. Everything looks as it should. I'm going to stop my recorder, and I'm immediately brought back inside of the K6 Cloud. Now, I have a few options that I can apply to my recording, specifically where I want to house this recording, maybe within inside of my new project folder. I can give this a custom recording name. And then I have the option to bring this into the test builder or script editor. For the time being, we're going to pick up with the test builder here and demonstrate that functionality, as we've already taken a look at the script editor. And then I have a few options directly below that I can apply to my recording as well. The first is correlation of request and response data. So if we detect any CSRF elements that are part of your recording, we'll do our best to correlate those values. Directly below that, left unchecked by default, is the inclusion of static assets. And the reasoning for this is 9 times out of 10, the elements are served up from a CDN provider. So unless you're trying to test the performance of your CDN provider, you normally wouldn't include these in your results data. Lastly, we have the ability to include sleep times. Sleep times are beneficial twofold. First, it prevents the load generators from becoming overworked, thus creating race conditions. The second, sleep conditions actually emulate actual user behavior, thus leaving you with more authentic performance data. And last but not least, we have third-party domains filtering. So if we detect any Google fonts, APIs, analytics, etc., we will omit those unless you select below. So we're going to save our recording, bring it in, and we're going to take a look at it with inside of the test builder. For the time being, we're going to skip past our load zones, ramping views, thresholds, cloud APM, and take a look at our request behind our script here. So taking a look, if we needed to add requests, we can simply, at the click of a button, add additional requests. If we wanted to, we could change this from maybe a GET request. Maybe we're posting some data, so we can change this to a POST request, or any of the other requests within inside of here. And then I simply just pass in my API endpoint here. Now I'm going to remove that and just hop right into our request. So all of our requests are grouped according to the pages that have been recorded. So with that, we have page 1, which was our e-commerce site. We made a post request here. We captured some header information, as well as our add to cart query parameter. And then we captured the product that was being posted to our cart here. We slept for 2 seconds. Then we came to our cart. We made a GET request, captured some header information, saw what was inside of our cart, slept for 4.6 seconds. Coming down to page 3, we began the checkout process. We made a GET request, reading what was inside of the checkout process. We captured some header information, slept for a second, made a POST request, passing in the parameters that needed to be added, such as the billing information to update the order review. We slept for 8.9 seconds, and then we passed the user information that was captured as part of this order with inside of it to the checkout process. Finally, sleeping for almost 4 seconds. Coming to our last page where we've completed the order, we made a GET request reading the information that was part of our order and captured that query parameter. Slept for 1.2 seconds, and then finally ending with our AJAX refreshment. Now, where the real magic comes in is I just captured the HAR recording and brought it into the test builder. Now, I can flip this switch from the test builder to the script editor, and voila, a test script has been automatically created for me. Now, it cut down on some manual coding from my end, and additionally, I now have this full test script with all the logic behind my test. What I can do now is I can select everything, copy the script, bring it to my local IDE for any changes or version control. I can create the test as is from the script that's been generated and save that and run it at a later date with inside of the K6 Cloud. Or there are a few changes that I can make to the parameters with inside of the options object. So coming up to our load zones first, starting here, we can add additional load zones. Let's say I have a use case where most of my clients are based within Great Britain, and then I have a few additional clients based globally in Sao Paulo. So what I want to do here is maybe I want to do a split distribution. I want to push most of my load to Sao Paulo. I'll push a little bit more to Great Britain, or I want to push most of my load to Great Britain, some to Sao Paulo, and some to Ashburn. So I have a globally distributed test here. Additionally, I'm going to come down to my ramping virtual users, or the stages of my test. 20 virtual users looks kind of low, so I'm going to go ahead and modify this. I'm going to throw maybe 200 virtual users at it. So during that first minute, I'm going to scale up to 200 virtual users, hold them for a duration of 3 minutes and 30 seconds. And then during the last minute, I'll scale down to 0 virtual users in my test. We have our thresholds, so we can build new thresholds behind our test. Let's say we want to do a response time metric across all URLs. We want to test it according to the 95th percentile for a condition less than 1,000 milliseconds. And we want to be a little bit strict with this threshold, so we're going to set the stop test flag here as well. Coming down, so we have our Cloud APM section where we can create new configurations, but we need to save that first. So we're going to go ahead and save that, and we can create a new configuration. I'm going to back up. And lastly, we have our requests as we've seen. So I'm going to go ahead and convert the script from the builder to the script editor. And now we can see the changes that I've implemented using my GUI here. I now have 3 load zones, with most of my load being pushed towards London, also split between Sao Paulo and Ashburn. I have 200 virtual users across a 5-minute and 30-second duration. And then I have that threshold that we included, the HTTP request duration threshold measured across the 95th percentile for a condition less than 1,000 milliseconds. And we have that abort on fail flag set to true. So if this threshold is exceeded, the test will stop completely and output metrics to either the K6 Cloud or to the command line if run locally. So we're going to hook up our IDE here and take a look at a pre-composed test script. I'm going to go ahead and get rid of my integrated terminal just so we can take a look at some of the logic here. Now, starting off with our test script, we're going to be importing a few methods to help us out. So we're importing HTTP, allowing us to make HTTP requests. We're going to import check, group, and sleep from K6, a few methods that will help us out a little bit later. And then we're going to import count and rate and trend, allowing us to configure custom metrics. Additionally, and most noticeably, we're going to import random in between from our JS hosted library. And then we have this users.json document here. Taking a look, so I have 6 users with inside of here. I have 1 user with valid credentials. This is a hint. We intentionally designed this test to fail, thus producing some custom metrics on the back end. So we're going to open up that document, parse in the JSON data, save that to our login data object here. Getting into our options object. So we have our stages or ramping profiles. We've configured a 200 virtual user 5-minute load test. Coming down to our thresholds, we have 3 unique thresholds with inside of here. The first is an HTTP request duration threshold measured across the 95th percentile for a condition less than 100 milliseconds. The second HTTP request duration threshold, very similar to the first, but here we're introducing the concept of tagging. Tagging allows us to visualize the individual metric being measured across this given threshold. And while I don't believe that anybody would measure across the 73rd percentile, we wanted to illustrate this, just demonstrating that our percentiles are not rigid by any means. Lastly, we have our check failure rating, measuring for a rate less than 30%. We then get into our K6 Cloud extension. We have our project ID, which can be sourced from the top of our project folder, if you recall. So we can copy that, come back to our ID, plug that in, and we're all ready to go. We have the name of our test, Insights Demo with Cloud Execution. Again, just a method of good practice here, especially if you're working with inside of development folders that have naming conventions. You want to make sure that you're triggering the right test. We then have our load distributions. This has been configured across 3 load zones, Dublin, Ashburn, and Columbus, with most of my load being pushed across Columbus. Additionally here, we have a note that we'll be passing as an environment variable. So if you have a note for one of your developers, maybe you want to push a test so that they can review it at a later date, you can include a note as an environment variable. Moving down to line 33, I have a counter for my successful logins, a rate for my check failure rating, and my trend for time to first byte. And then we get to the export default function. As previously mentioned, the export default function is critically important for 2 reasons. This is the main housing for all of your logic behind your test script. This is also the main entry point for all of your virtual users. So we're going to open this up here, take a look. We're going to enter into our front page group. We're going to define our response object, setting it equal to null. We set our response object equal to our get request against our test URL, bringing in our math.round and random in-between function to generate a position between 1 and 2000. And then here we're going to apply some tags such as a name tag with our test URL and an aggregated flag, because I want to visualize my initial HTTP request as part of my test script. Additionally, I'm going to run some checks here, making sure that the homepage body size is given length and that our homepage welcome header is present on the page. We record our check failures, record our time to first byte, tagging that with the time to first byte URL. And then we move into our static assets group. We let our response object, we let our response object equal our batch method here. And as I mentioned a little bit earlier, so the batch method gives you an added layer of concurrency while making parallel requests. So in the example configured below, I'm making a get request to my CSS, another to the JS here, and I'm applying some tags such as a static asset tag, other tag, and name tag to help out with the visualization a little bit later. I run a check, making sure that my style sheet is given length. I record my check failures, record my time to first byte, tagging that with the time to first byte URL and static asset tag. And then I close my static assets group. I close my login group, and then I let my virtual users sleep for a random duration between 1 and 15 seconds. Then I begin to move into my login group here. I let my response object equal my get requests against my messages page. I run a check making sure no unauthorized users are present on the page. I extract the CSRF token using the response object as well as the HTML. I find the input name CSRF token, take the first value, and then I extract that value. I run a check, or I record my check failure rating. And then here's where we begin to use that users.json document. So here I'm bringing in my math.floor and math.random to randomly loop through that users.json document. And then I select their position and save that to my position variable. On line 99, I reuse my position variable to extract the credentials from that user's position, and I save them to my credentials object. And then on line 101, I set my response object equal to my post request against the login page, passing in my username, password, and that CSRF token. And then I run a check making sure that the logged in welcome header is present on the page. Just want to move this over a little bit so everybody can see the logic. Now coming down, I run a check, making sure that the logged in welcome header is present. I record my successful logins, record my check failures, tagging that with the page login, record my time to first byte, tagging that with the time to first byte URL. I sleep for 10 seconds, and then I console log my note. I close my login group and close my export default function. Now a common question that we receive is, I've reached the end of my test script, my test has been executed. What do my virtual users do now that they've reached the end of the test script and there's time remaining on the test? And it's an excellent question. So with that, our virtual users will loop over the logic stored inside of our export default function until time has expired on the test. So with the logic we have stored in our export default function and a 200 virtual user 5-minute load test, we're capable of achieving roughly 2,500 unique session IDs. So something to give the folks watching an idea on the capabilities of our load generators, as we spoke about a little bit earlier. So with that, I'm going to go ahead and pull up an integrated terminal here inside of VS Code and make this a little bit bigger. I'm going to go ahead and run the command k6 run, or k6, to validate that k6 is installed on my local machine. I see k6 is installed here. So I have a list of available commands as well as some flags that we can set up with the k6 open source solution. So in addition to this, k6 has one distinct run mode for the open source solution, which is k6 run. Here we can use k6 open source to do some quick and local debugging of our test scripts before we push this up to the k6 cloud. So I'm going to use a shorter test script for demo purposes. I'm going to pass in the name of my test script here. I'm going to set a flag for my iterator, which is -i. I'll do one iteration. I'll set another flag -u for our virtual users. I'll do one virtual user. And then lastly, we'll set a flag here for http-debug. Immediately after kicking that off, we get a copy of the request and response data, a copy of the page data, a copy of our test script, some more request and response data. We see that our checks came back successfully, and we have the metrics captured by k6 open source. Now, another common question we receive is, how can I get my results in a different format? Maybe I don't want the raw metrics. I want to see these in JSON data because I want to make a REST API out of my metrics or something along the lines of that. So what we can do is modify the flag for our test to --out and say I want it in a JSON format. I kick that off. I get my metrics back in a JSON format. Now, last but not least, one of the most common uses is testing private APIs that may be behind a firewall. So with k6 open source, what we can do is do k6 run, the name of our test script, and then we can set a flag here for -o cloud. What this will tell k6 to do is execute locally, bundle up our results data, and then stream that directly to the k6 cloud, where we'll pull it down and then present it inside of the dashboards that we've created. Now, the viewers may be asking yourselves, okay, well, how do I access the cloud method of execution? Because you told me that k6 open source only has one run mode. This can be achieved with a k6 cloud account, whether that's a trial, a full paid subscription, whatever the case may be, by running k6 login cloud, passing in my email as well as my password, and authenticating that way. Additionally, as I demonstrated during the beginning of the walkthrough, we can set a flag here, come back to the web app, grab our API token from our user settings, and then pass that as an argument on the command line. Once authenticated, we can take advantage of the cloud method of execution, which is k6 cloud. And now we're going to trigger a test against the test script that we just walked through, which was website.js. I'm going to set up a flag here for my environment variable. I'm going to set my note equal to, let's say, new test 10/1/2021. And now I'm going to trigger this. k6 cloud is now taking a look at my test. In the terminal, I can validate that my method of execution is cloud. The script is website.js. I have a link to the output, which directs me to the k6 cloud. At this stage of the game, k6 is looping through my initialization context, importing any dependencies, taking a look at that users.json file, including it inside of my test, setting up my stages, my thresholds, and an extension inside of the k6 cloud where I'm spitting up that load zone, and then including my note as an environment variable here. We then set up the custom metrics, and k6 will loop through the logic stored inside of my export default function. Within a second, I believe this will begin to run. Yep, and we can see our tests begin to run in real time. So this will start to begin to console log our our notes. So I'm going to access our result data here now. So with inside of the K6 Cloud, I can visualize my test running in real time. I can see the test duration remaining, total test duration, total number of virtual users, distributed load zones. If I hover over these load zones, I can see the public IP as well as the instance size. I can see who this test was started by, and I can also read that note that I passed as an environment variable. Directly below that, we have the performance overview. We can see the requests made, HTTP failures, active virtual users, RPS, and average response time. And if we hover over the graph below, we can see the active virtual users as they begin to enter our test script, response time metric, request rating metric, and failed request rate. Directly below that, we have our performance insights. These are K6's own proprietary algorithms that we've developed in-house. What they'll do is scan through your results data. If we detect any anomalies behind your results data, we'll make some suggestions on how you could remediate those issues inside of your test. So taking a look here, we have about 4 minutes left behind our test. So maybe you want to come down, take a look. So I have 3 thresholds behind my test. My test is continuing to run. Everything looks good for now. So maybe you want to come back to the terminal. I see that my console log of the note is console logging, and this can get a little noisy. And we also see our test running in real time, so everything's working as it should. None of my thresholds have been exceeded to the point of failure yet. Okay, so I'm coming back here, taking a look at my thresholds. I can open these thresholds up. I see that my check failure rating has been exceeded. It exceeded that rate of 30%, returning a rate closer to 42%, letting me know that there's a problem with my check failure rating. What I can do now is add this chart to our analysis tab. Also coming over and taking a look at our checks, I see that our homepage body size is completely failing. However, our logged in welcome header is populating about 1/3 of the time. I'm going to open that up, add it to our analysis tab, and then wrapping up with our HTTP request here. I want to take a look at my initial HTTP request. From within inside of here, I have the ability to change this metric from the response time to the request rating, response time percentiles, or the timing breakdown. I have the ability to change the aggregation from the average to the median, min, max, standard deviation, or any of the 90th percentiles. And then I can also visualize this according to a specified load zone. Maybe we want to visualize this according to Columbus, as that's where we push the most amount of load behind this test. So I'm going to add that chart to our analysis tab, finally wrapping up with our analysis tab here. So we have the comparison chart here that's populated with our VUs, response time metric, request rating, and failed request rate. And now I want to correlate some metrics that I've selected behind my test. So I'm going to include that check failure rating, logged in welcome header present, and timing breakdown. And then as I hover over the metrics that I've selected, I can view all the data in a correlated and meaningful way, and I can derive those insights from the metrics here. I also have the ability to add a metric. Maybe we want to include a group duration metric across all groups behind our test. I can also add that quickly and easily here. Now, one thing I want to get to before we run out of time, one of our viewers had a question about exporting metrics. So with that, we can export by clicking this 3 arrow. We can share the test results by generating a shareable link, as I discussed. We can copy that, and let's open up a blank page here. I'm going to plug in that URL inside of our web browser. And here we can see our test results.
Could you paste that into the chat here so that I can put it in the video chat as well, just so people can have a look as well?
Yeah, absolutely. So, and as I mentioned before, anybody in the organization can access this. They don't need to be associated with the K6 Cloud subscription. Now, coming back inside of the web app, I'm going to change gears a little bit just to demonstrate that we do have the ability to export our metrics in different ways. So if we come back inside of here, we can export our data inside of a CSV document. And then last but not least, we also have that ability to generate a PDF summary report. Extremely beneficial if you have any, let's say, high-level executives, board members, etc., that are not used to seeing the raw data and want to see it in a meaningful way. We have this executive PDF summary. We have a little bit of customizability with inside of here. You have the ability to select the metrics for this given report. We can go ahead and add a note. And once we're ready, we can generate our PDF here. This will assemble all the custom metrics that we've selected behind our report, as well as any custom notes that have been integrated with inside of that given report. It will arrive in the form of a download with inside of your downloads folder. And from there, you could either print the document out, upload it to a drive, or attach it as an email to its recipient. To show you the finalized version of the report, here we have our K6 Cloud Demo Executive Summary Report, and we have those metrics that we selected and our note saved successfully here.
And if somebody wants to get started with that and wants to book a demo with you or just a conversation, what's the best way for them to do that?
So the easiest way would be just sending an email directly to either sales@k6.io or sending an email to me at bill@k6.io.
Thank you, Bill, and we'll see you next week.
Yeah, absolutely. Thanks,
Bye.
everybody.